alpha, beta, gamma minus alpha such that A square equal to I the identity matrix then. So let us work out A square. What is the given relation? A square equal to I. So what is A? Alpha, beta, gamma minus alpha. Multiply with the same alpha, beta, gamma minus alpha. Identity matrix of second order 1, 0, 0, 1. So multiply the two, you get, and how do you multiply? Both the matrices are square matrix of order 2 by 2, so the resultant matrix will also be of the order 2 by 2, and of course on the right hand side we have the unit matrix. Now multiplying, you know you multiply row to column, so you have alpha square plus beta gamma, multiplying to the second column, you know you get alpha beta minus alpha beta, so you get 0. And now continue the same with the second column, you get alpha gamma minus alpha gamma, that is 0, and multiplying to the second column, you get beta gamma minus minus plus alpha square. And now equating, you know, the respective elements, you have alpha square plus beta gamma equal to 1. Even from A to 2 element, these elements, you get 1. So this is the relation. Or you get alpha square plus beta gamma minus 1. Just check up with which choice it matches, or it may be rewritten as, because in the answer it is given like this, 1 minus alpha square minus beta gamma equal to 0. Now check with which result it matches. It matches with choice C. Next, question 14. If the matrix A is both symmetric and skew symmetric, then which of the choices is correct? Let's see how can a matrix be symmetric as well as skew symmetric. So let me start with a matrix. Let us A is a skew symmetric matrix. Let us consider A as a skew symmetric matrix. A equal to. What is the property of skew symmetric? Let me choose it a matrix of order 3 by 3. You know, the diagonal elements of skew symmetric matrix are definitely 0. And if I take the elements here as A, B, C, then diagonally opposite the elements, if it is A, here also you will have A, not merely A but negative A, and negative B and negative C. It is easy to check that it is a skew symmetric matrix. Let us work out A dash, transpose of it. Transpose of it, take the elements of first row, 0, A, B in the first column, and that of second row, minus A, 0, C in the second column, and that of the third row, minus B, minus C, 0 in the third column. It is easy to see that if you take minus common out of it, it will be exactly same as A. So that means it is a skew symmetric matrix. But it is also given, okay, I'll show you. Take minus common out of it. What do you get? 0, A, B, minus A, 0, C, and minus B, minus C, 0, which is nothing but A, so minus A. So we have verified that the example which we have chosen is of skew symmetric kind. But it is further given, also it is given that A is symmetric. And if A is symmetric matrix, then A dash should be same as A. So now equating the corresponding elements, what do you get? 0 of course is 0, A11. And if I take A12, A equal to negative 1. Similarly, you get B equal to negative B, and you get C equal to negative C. How can a real number be equal to, can 5 be equal to negative 5? No. The only possibility is that A has to be 0. So A is 0, B is 0, C is 0. And if you take A, B, C as 0, what will be the matrix which I have chosen? 0, 0, 0 was already there, and even rest of the elements will be 0. So that means then A is nothing but a 0 matrix. And which choice is this? You check up. This is your B choice. So B choice is the correct answer. 15th sum. If A is a squared matrix such that A square equal to A, it is given to us that A square is A, then we have to work out the value of I plus A whole cube minus 7. Let me write few more results, that wherever you come across I square or I cube, that can also be replaced by I, because identity matrix multiplied by itself twice or thrice will keep it the same, and even if I have to use AI equal to IA, will remain equal to A. So using these results, we can continue. Now I plus A whole cube, you apply ordinary A plus B algebra formula. A plus B whole cube, you know is what? A cube plus B cube plus 3A square B plus 3AB square. Apply that. So you get I cube plus 3I square A plus 3IA square and plus A cube and minus 7. So I have applied ordinary A plus B whole cube, and now using the results, I cube can be replaced by I, you know, and plus 3 times I square can be replaced by IA, plus 3 times I, and you know A square can be replaced by A only. And what about A cube? A cube first may be written as A into A square. Wait for a minute, minus 7. Now we get I, and this 3 IA can be written as A only, so 3A. Plus IA again can be written as A, so 3A. This A square is given to us as equal to A, so here you get plus A into A and minus 7A. One more step, 3A plus 3A, you get 6A. And here you get A into A square minus 7A. Now A square again, you know, it is given that A square equal to A. So what do you get now? I plus 6A plus A minus 7A. So you get I 6A plus A 7A minus 7A. So 7A and 7A will cancel. You simply left with the identity matrix. Just check out which choice is this. This is your C choice, that is the answer.